So remind you what the formula is. This said that the integral of f of x times g prime x dx is equal to f of x g of x minus the integral of f prime of x g of x. That's the indefinite form, and in the definite form you need to put limits here. You need to evaluate this one at x equals b and subtract the value at x equals a. And you need to put limits in here too. Okay, so that's the general formula we'll be using for these examples. Now again, I'm going to do a couple of examples. Okay, so here's the first one. This is going to be a definite integral from 0 to pi of x sine x dx. Okay. So integration by parts works generally if you've got something you know how to integrate times x to the power n. You can always do this by integration by parts a number of times. So in this case, I'm going to say g prime of x is equal to sine x and f of x is equal to x. So therefore you need to integrate g prime and differentiate f. So the integral of sine is minus cos, and the derivative of x is 1. Okay, so I put those results in the formula here. So this gives me f times g, that's x times minus cos x, between pi and 0, minus the integral between 0 and pi, between 0 and pi of f prime times g, that's 1 times sine, that's 1 times minus cos, so that becomes minus plus cos x dx. Okay. Now when x is equal to pi, in here I get minus pi cos pi, and when x is equal to 0 I get plus 0 times cos of 0. Okay, that's this term here, and then the integral of cos is sine, so I get plus sine x between 0 and pi. So cos of pi is minus 1, so this first term just gives me pi, and this term gives me sine of pi minus sine of 0. But both of those things are equal to 0, so the answer is just pi. Okay, so that's an example of getting integration by parts. Now the same method works on any function where it's x times something you know how to integrate. So if I do another similar example quickly, integral of x e to the x dx. Okay, so in this case, as before, I choose f of x to be equal to x, and therefore f prime of x is 1, and g prime of x is e to the x, so g of x is also equal to e to the x in this example. Then putting it into the formula here, you get f times g, that's x e to the x, minus the integral of f prime times g, that's e to the x dx, which is x e to the x minus e to the x plus c. So I can write this as x minus 1 e to the x plus c. Okay, and again, if you want to check, you can just differentiate this function, and you should get x times e to the x. Okay, now the same method works even if it's not just x, but it's x squared and so on. And let me show you how that works. So I'll just do one final example. Integral of x squared times cos x dx. Except here you need to do integration by parts twice. So here f of x is x squared, so f prime of x is 2x, g prime of x is cos x, so g of x is sine x. So this is going to give you x squared sine x minus the integral of 2x cos x dx. So this is x squared sine x minus twice times the integral of x cos x dx. And this one, sorry, this one is g, so this should be sine. Sine, and this is sine. That's better. Okay. And then this integral here is the same as we've got here. So this is x squared sine x minus 2 times this minus x cos x plus the integral of cos, which is sine. So putting that all together, this gives you x squared minus 2 sine x plus c, of course. X squared minus 2 sine x plus 2x cos x plus c. Okay, and again you can check if you differentiate this, you should get x squared cos x. Okay, so here you had to do differentiation by parts twice. I did it first once here, and then second to go from here to there. Okay, a final example, which is not clearly an integration by parts, but is one where you can do it, is suppose you want to integrate an inverse function. So if you want to integrate something like log of x dx, then one way you can do this is by imagining that there's a second function 1 in there, and then integrating the function 1. So in other words, you take this and you say that f of x is log of x, so therefore f prime of x is 1 over x, and g prime of x is 1, this 1 here, so therefore g of x is x. Then if you apply the integration by parts formula, you get f times g, that's x log x, minus the integral of f prime times g, that's the integral of 1 over x times x dx. But this, therefore, is x log x. The integral of 1 is just x, so I get minus x plus c. Okay. So this is one way you can integrate a function like this. Okay, there's another way you can do it by substitution as well, so let me just show you the substitution way as well. I've got the integral of log x dx, and I say that u is equal to log x. So this means du by dx is equal to 1 over x, but this is e to the minus u from here. So therefore dx is equal to e to the u du, so therefore this becomes the integral of u times e to the u du. And then this one is the same as you've got here, which you can do by parts. So it's just the same but with x replaced by u, so this is u minus 1 e to the u plus c. And then finally, if I put what in what is u, then u minus 1 is log x minus 1 e to the u is just x plus c. Okay, and you can easily check that these two answers are the same, right? Okay. So this same method, this trick of putting 1 here, also works if you've got if you've got integrals of other inverse functions. So for example, the integral of arc sine x dx, or the integral of arc tan of x dx, can also be done in this way.